So we have a nice little experiment today involving galvanic cells. What we're going to do is take two pieces of filter paper and put them in a petri dish so they overlap in the center. And then we're going to take aqueous solutions of a number of metal cations and put them on the different pieces of filter paper. We're then going to put a piece of metal of that same ion on that, connect them with potassium nitrate saturated aqueous solution, and then connect the electrodes of our potentiometer and see what the EMF of that cell is. In this way, we'll be able to figure out which of the metals is more active and which of the metals is less active. Now we're trying copper and silver. Put the copper solution on the copper side. The silver solution on the silver side. Create our salt bridge between the two. Red electrode on the copper, black on the silver. Minus 320 seems to be that reading. And so that's the copper and silver reading. Now we're going to try magnesium and copper. Put copper on solution. A piece of copper. Magnesium solution on the magnesium. Bring them together with our potassium salt. Red electrode on copper, black on magnesium. Okay. So we're doing copper and lead. Put the copper solution on the copper side. With a piece of copper. Lead solution on the lead side. The piece of lead, our potassium nitrate solution to unite them in the middle. Red electrode on copper, black electrode on lead. $474 seems to be our reading. So this time we're trying copper and zinc. Put the copper solution in the piece of copper on one side. The zinc solution in the piece of zinc on its side. Our saturated potassium nitrate solution to bring them together. Red electrode on copper, black electrode on zinc. Looks like 820 is our reading. Now we're going to try silver and magnesium. Silver in the silver solution. A piece of silver. Magnesium. Magnesium solution. Piece of magnesium. Bring them together with our potassium nitrate solution. Red electrode on silver, black on magnesium. 2000 millivolts. Now we're going to try silver and lead. Silver on the silver side, lead on the lead side. Our salt solution of the potassium nitrate. Red on silver, black on lead. So our reading's apparently 600 volts, millivolts. Now we're going to take a reading of silver and zinc. Silver solution for silver. Zinc solution for zinc. Establish our salt bridge between the two. Red on silver, black on zinc. .998 is our reading. Now we're going to try lead and magnesium. Lead solution and a piece of lead. Magnesium and a piece of magnesium. Red electrode on lead, black on magnesium. $1,260 looks like. Now we're going to try lead and zinc. Put the lead solution on the lead side and a piece of zinc lead metal. Zinc solution on the zinc side. Piece of zinc. Bring them together with our saturated potassium solution. Red electrode on lead, black on zinc. $370 seems to be our reading. Now we're going to try zinc and magnesium. Zinc, a piece of zinc. Magnesium, a piece piece of magnesium. Our salt solution. Red electrode on zinc, black on magnesium. Looks like it's settling about 684. Now that we have all our basic data, we need to establish which way the current is in fact flowing in each of our cells. Most of our values have been positive, one of them at least has been negative, and so we need to actually figure out which way the electrons are going, so we can figure out which of the metals is most active and which one isn't. And the way we're going to do that is fairly simple. We're going to set up a concentration cell. We're going to put in on one piece of filter paper 1 molar copper ions, and on the other one 0.01 molar copper ions. When we put the piece of metals on, add the potassium nitrate solution, and then put on the electrodes. All the current is going to be a result of a concentration cell, in which the electrons are obviously flowing from the less concentrated solution to the more concentrated solution, because that's the way a concentration cell works. We now need to establish which way the electrons are flowing, and the way we do that is going to be fairly simple. We made a solution that is 1 molar copper nitrate and a solution which is 0.01 molar copper nitrate. And we'll simply check the potential between those two. The only difference between the two solutions, of course, being copper concentration, which means we'll generate a concentration cell. Put our two solutions on their respective pieces of paper, add a piece of metal, include our potassium nitrate solution, red electrode on 1 molar, black electrode on 0.01 molar. And we're getting a current of 30 millivolts. Now that we've figured out which way the electrons go in each of the different cells, we can figure out which of the metals are the most active down to which of the metals are the least active. And at that point, you can simply put the arrows into the equations and indicate what the results were and rank the metals most active to the least active metals. And that's the end of the experiment. Go have a nice day.